So we have another problem here before us, and it reads, in a party of 30 kids, 12 were served Coca-Cola drink, while 14 were served Pepsi-Cola drink. If 9 kids were served only Coca-Cola, that means were served Coca-Cola but not Pepsi-Cola. Question says find the number of kids served both drinks and the number of kids served at least one type of drinks. Finally, the number of kids not served any of the drinks. So we proceed using the Venn diagram to denote these sets. From the information we have, we are dealing with Pepsi Cola and Coca-Cola. So we call the set of Coca-Cola C and call Pepsi Cola P. So from the information we have that the universal set comprises of 30 kids. That means the one under our consideration, the one we are considering, 30 kids. So it proceeds further to say that 12 were served Coca-Cola drink. So the cardinality of Coca-Cola now, the cardinality of Coca-Cola is 12. The cardinality of Pepsi-Cola is 14. Then it says if 9 kids were served Coca-Cola only, that means 9 kids were served only Coca-Cola but not Pepsi-Cola. That means cardinality of Coca-Cola intersection Pepsi-Cola complement equals 9. Coca-Cola intersection Pepsi-Cola complement is only this part here. From the diagram we shaded, we saw that Coca-Cola intersection Pepsi-Cola complement should be only this part here. So since we have gotten only this part here, we can have that this is 9 in this part alone. So the first question says the number of students served both drinks. Okay, so we are first of all we are looking for cardinality of Coca-Cola intersection Pepsi-Cola. So if you look now, since we have that our Coca-Cola, those served Coca-Cola were 12, and we saw from the equation that those served only Coca-Cola is 9. That means a number of people from these people served Coca-Cola also took Pepsi-Cola, and we clearly saw that cardinality of Coca-Cola intersection Pepsi-Cola complement will be those served Coca-Cola, which is 12, minus those served Coca-Cola but not Pepsi-Cola, which is 9. So have that those served both drinks. We have 3 people here taking both drinks. So the next question now says the number of kids served at least one type of drink. So we go over to find the number served only Pepsi-Cola. So we can tell those that took only one drink. So those that have served only Pepsi-Cola, we have it as cardinality of Coca-Cola complement intersection Pepsi-Cola. This is the number of those that took only Pepsi-Cola, because Pepsi-Cola is intersecting the complement of Coca-Cola. That means this part here. So when we take away this intersection, we have only this. So if we have here as 14, so we have that those served only Pepsi-Cola is 14 minus 3, which is 11. So we have that 11 people took Pepsi-Cola only. So the next question said the number of kids served at least. At least means it's either they took one drink or more. The number of kids served at least one type of drink. Okay, the number of kids served one type of drink is cardinality of Pepsi-Cola union Coca-Cola. Remember, the union means anything that is either is here or is in both of them. So we have as 9 plus 3 plus 11, which you have as, so you comment it, put in the comment below cardinality of Pepsi-Cola union Coca-Cola. This you just put it in the comment below. So finally, the number of kids not served any of the drink. That means the complement of this does not serve any of the drink. They just came to the party, maybe they feel like not drinking, or they were not just served any drink. So you solve it is cardinality of P union C or complement. So you put it also in the comment below and we'll get to correct check the right answer. So in this question here, we'll solve Venn diagram involving 3 sets. So thank you very much. Subscribe.